Okay guys, so let's get started with this lecture by seeing types of electrodes. So first is inert electrode, or which is non-reactive. So this do not participate in reaction. And second, let's see the reactive electrodes. Which can participate in reaction. Okay. Next, let's see the electrolysis of 1 CuSO4 using Cu electrode or copper electrode. Using copper electrode. So we have this apparatus wherein we have copper electrode, which is taken as anode, positive sign. Why? Because we have attached a external battery to the same. Okay, and this is negative electrode or cathode. So here we already know that oxidation takes place and reduction takes place here. So in here at anode, what we can see is by the way, the solution in which the apparatus is placed in is CuSO4. We have already mentioned it, 1 CuSO4 aqueous solution. So at anode, what we can write is 2 moles of SO4 2 minus can get converted into S2O 2 minus aqueous plus 2 electrons. So E naught OP for this reaction is minus 2.01 volts. We can also have oxidation of water to form 4H plus aqueous O2G plus 4 electrons. E naught OP for this reaction would be minus 1.23 volts. And finally we can have CuS forming Cu plus 2 aqueous with the evolution of 2 electrons. So E naught OP for this reaction would be minus, let's say, 0.34 volt. And at cathode, what we see is the reduction of H plus to form H2G. So for this case, E naught RP would be equals to 0.0 volts. And we can also have Cu plus 2 aqueous combining with 2 electrons and forming CuS. So E naught RP for this reaction is 0.34 volts. Okay, so we can write that the overall reaction would be, as this is greater than this, all these two. So at anode, what we can write is CuS would be getting converted into Cu plus 2, and at cathode as well we can see that reduction potential of conversion of Cu plus 2 to Cu is greater than the reduction potential of water, or the reduction potential of H plus aqueous rather. So we can write that this would be favorable for the reaction at cathode. So overall we can see the reaction, that if we write the overall cell reaction, then we can see that CuS is getting converted into CuS. Okay, so this is nothing but the dissolution of copper at anode, and this is deposition of copper at cathode. Okay, so in the apparatus we can write that the copper is getting dissolved here and it is getting formed here. Okay, so this is the reaction which we are going to see. Okay, so note that if electrodes are inert, then at anode we can see the evolution of or formation of O2G, and at cathode what we can see is again at cathode CuS would be deposited. And why is this the case? Because we have already seen that if the electrodes are inert, then it will not take, or it will not participate rather in the electrolysis. So this SO4 2 minus is coming from Cu plus 2 and SO4 2 minus, and it would not actually be participating on this electrode, but this H2OL is the medium which is facilitating all the electrolysis. So again, even if the oxidation of water takes place, it will not involve any reaction on the electrode, so simply oxygen gas would evolve. So in that case, at anode, oxygen gas would be getting formed, and again if the reduction potential of copper is greater than the reduction potential of water, or rather H plus, then although this electrode is not participating in the reaction, but the Cu plus 2 can still deposit itself on the inert electrode. Okay, next let's see what if the anode of, or rather the anode of copper is impure and it contains impurities like zinc, AgAu, gold, silver, etc. So what we can see is, in the vessel where the reaction is taking place at anode, if it is impure, then what we can see is if the oxidation potential of these impurities is greater than the oxidation potential of copper, then this will be getting oxidized. So we can have copper here present along with these impurities like Fe, Zn and AgAu. So we can write that Fe and Zn would be getting oxidized to Fe plus 2 and Zn plus 2. So at anode what we can see is we can have Zns converting itself into Zn plus 2 aqueous and 2 electrons, Fes converting itself into Fe plus 2 and 2 electrons, and similarly Cus converting itself into Cu plus 2 and 2 electrons. But note that at cathode, Zn plus 2 and Fe plus 2 cannot reduce, as their reduction potential means as their oxidation potential is higher, then their reduction potential will be much lower than the reduction potential of copper. Hence these will not be getting reduced. Okay, so Zn plus 2 and Fe plus 2 cannot reduce as their standard reduction potential is lower than standard reduction potential of copper plus 2. Okay, hence only Cu plus 2 would be getting deposited on the cathode. Other Cu would be getting deposited on the cathode by converting from Cu plus 2 to Cus. So with this we come to the end of this lecture. We'll meet in the next lecture. So till then, good luck and goodbye.